let's do something very interesting. Let's visualize, that is understand in a diagram, let's visualize factorization of a quadratic polynomial. And that method can be used to find the roots also. So we'll visualize both. But first, let's visualize factorization of a quadratic polynomial. For example, take x square plus 5x plus 6. Now when it's an equation, we'll make it equal to 0. Now, what is x square in a diagram? X square is nothing but you take a square with side x. Now, to get 5x, first let's take x. What is x? If you want to visualize here, x is a rectangle. So take a rectangle here with length on top of this x square, where length is x, but take breadth as 1. So you get x square plus x. Now, if I take this 5 times like this, I'll get x square plus 5x. So x square plus 5x is the area of this rectangle. 6 is still outside. But as per our method of factorization, what we are supposed to do is that 6 into 1, you are supposed to write as product of two numbers. You can either write it as 6 into 1. So in a rectangle, it will look like this, where length is 6 and breadth is 1. Or you can take it as 3 into 2, where the length is 3 and breadth is 2. But while doing this, you should make sure that sum of this length and breadth is matching with the coefficient of x, or 5x in this case. Now that is why this 3 and 2 will exactly match. So now coming back to this area x square plus 5x, this 5x you can split as 3x and 2x. So I'll bring this 3x down here, 2x is left on top. Now this rectangle will get completed when, what is the remaining region here? That rectangle is with length 3 and breadth 2. So I can directly take this 3 by 2 rectangle and fill it here. So it's a complete rectangle now with length x plus 3 and breadth x plus 2. So area of this rectangle is nothing but, if I take length into breadth, x square plus 5x plus 6, which is our original expression. So x square plus 5x plus 6, initially we had 3 separate diagrams, one square with area x square, rectangle with area 5x, another rectangle outside which I kept outside with area 6. But when you bring all of them together, we are still getting x square plus 5x plus 6, but we are factorizing it as length and breadth. Length is x plus 3 and breadth is x plus 2. So very interesting way to connect a method which otherwise can be very boring or monotonous when it comes to just factorizing the way we've been using numbers before. But when you visualize, I'm very sure it's very intuitive, interesting and easy. So we just visualized factorization of x square plus 5x plus 6. Now next, using the same thing, if I make it equal to 0, I'll get a quadratic equation. So solution for that is very easy to visualize here. That's what I'll do next. Now we can find the roots of the equation also. We already got x plus 3 into x plus 2 equal to 0, where visualizing x plus 3 is actually the length and x plus 2 is the breadth of this particular rectangle. So you can make the area of this rectangle 0 either by making length equal to 0, that is x plus 3 equal to 0 or x equal to minus 3, or by breadth equal to 0, which is x plus 2 equal to 0, where x will be equal to minus 2. So minus 3 and minus 2 are the roots of this quadratic equation. So visualizing this is, again, it's going to be very easy. If you relate with this diagram, now see this rectangle with length x plus 3 and breadth x plus 2. So when will it become 0? Here, x plus 3 is the length and x plus 2 is the breadth. You can either make the length 0 so that the rectangle area will become 0, or the breadth 0 so that again it will become 0. That is when x equal to minus 3 or x equal to minus 2. So the roots are x equal to minus 3 and minus 2. Now how can you visualize even this process? It's interesting. So from this rectangle of length x plus 3 and breadth x plus 2, now I can make length 0, assume that y-axis is here. So if I start pushing this to the left, this will start becoming negative. So when x is at minus 3, when x is minus 3, these two areas, that is what is there in red and what is there in green, will get cancelled out and the rectangle will disappear. Same way, if you want to make breadth 0, that is when I push this complete rectangle down, if I push this rectangle down, so it will start going below the x-axis. So here this will start becoming negative. When it's at -2, these two areas will get cancelled out and the rectangle will disappear again. That is why when x equal to -3 and x equal to -2, either when x equal to -3 or when x equal to -2, the rectangle is disappearing here because either length is becoming 0 or breadth is becoming 0. That is, from being 2-dimensional, you are making it 1-dimensional. It's actually becoming a line. So there is no area. So you can relate the two, what is happening here in numbers and what is happening in the diagram. Once you connect, it's becoming so simple. That's why you understand this completely now. So you know how to factorize a quadratic polynomial using numbers, and now you know how to visualize, not just how to factorize, and that's resulting in or that's helping you to find the roots. So I'm sure by this you have a much better understanding of factorizing quadratic polynomials.